Hello viewers, today I discuss interesting nature of continuity in nonlinear spaces. We follow it in classical definitions, but this definition is also true in nonlinear spaces also. And it is interesting nature to see this. Let's watch this video till the end. The viewer who are watching this video first time, they are advised to subscribe the channel and press the bell icon to get all the notification. Let's watch. If we are taking two nonlinear spaces, if it's say as in M, and if any point say x0 is defined and a mapping carry from these two nonlinear spaces, and here we find x0, our object f of x0, our object is to prove that this f is continuous at these points x0 and above all of these points, since this is arbitrary. Let's watch. If in M are nonlinear spaces, a mapping, if we consider it as f from N to M is continuous, and if we taking this considering point is x0, that is x0 in the space N, this point is satisfied coming from the classical definition. So if and only if to each epsilon greater than 0, that is a given epsilon, and there exists a delta greater than 0 such that our criteria, that is norm of x minus x0 is less than delta, which imply norm of fx minus fx0, this must be less than epsilon. This is our criteria. So it comes from the classical definitions where we used as mod, but here we use as a norms, because this is a higher dimensional figure and we use in functional analysis. Specifically, this functional analysis is the advanced part of linear algebra, where we consider many spaces like in dimensions, but we don't use these advantages easily in classical definitions, but it is a higher order and we use it in this manner. And finally, we are writing and set up our definitions criteria of the continuity. And we can also say that this function f is continuous on N, because we are taking in the nonlinear spaces, if and only if is continuous at each points of N, because there are the many points exist in this nonlinear spaces and this is continuous for all of those points in the N, in the nonlinear spaces. And we have find this reflections in also in M considering the nonlinear spaces. Already we are pictorially representing in the nonlinear spaces. We end our discussions here. If you like this video, like it, share it, and always subscribe the channel. Thanks for watching.